Hello. Hello friends, welcome to another video of Zeta Axis, and today we are going to see different river drainage patterns. So there are basically two basic classifications of river drainage pattern. One is based on the flow of the streams and it is classified into these categories. There could be several other categories, but these are the main categories. The second method of classification of river drainage system was given by W.M. Davis, and it is basically classified into these groups, and they are dependent not only the type of flow but also the origin of the stream. It also takes into account the origin of the stream as well as the flow direction and other characteristics. So today we are going to see only these classifications of rivers, and in the next video we will see the types of drainage by W.M. Davis. So here is the classification we are going to see today, where it is classified into dendritic, parallel, Trellis, rectangular, radial, centrifugal, centripetal, inland, annular, barbed and deranged. So we will see all these patterns in this video. So the first is dendritic pattern. The dendritic pattern is tree-shaped drainage pattern associated with the areas of homogeneous lithologies. So basically it is this kind of drainage pattern where the water is flowing from here towards this direction, and these are the branches. So you can see that these are like branches of trees which are coming from the main branch. So because of this look of this flow system, it is called dendritic system, because this is also like the nervous system in our body, where there is one main nervous system and then there are smaller dendrias. So if we consider this kind of topography where we have mountain and plain here, we will see that a main branch starts and then there are several branches which meet the main branch, and then there are sub branches which meet this branch, and there are further division of branches which will meet even these branches, and they will finally meet the main river. So this kind of flow is called dendritic pattern, and it is generally seen in the areas where there is homogeneous lithology, that is the rock, the base rock or the base landscape is more or less consistent. Horizontal or very gentle dipping strata is there, so the slope is horizontal or it is very gentle. Flat and rolling extensive topography surface having extremely low reliefs. So this is mainly seen in the areas where the relief or slope is not very high, and even the rock structure is consistent, as well as you will see that the slope is also consistent. Uniform lithography is ideal condition, that is, this is the idealized condition where we see this kind of flow, but it can also be seen in other types of situations. Most common pattern seen in most of the rivers, that is most of the rivers that flows in India, in the planar regions basically, they will have this kind of flow. So it is seen in Indus River, Ganga, Godavari, Mahanadi, Kaveri. So all these rivers, both in peninsular as well as Himalayan rivers, you will see that most of them have at least in some places, this kind of pattern. Here is another image which very closely shows you that this is the main stream over here, and then these are the sub branches of the main stream, and then there are these smaller branches, and these smaller branches also have smaller branches. So there are many small streams which make larger stream, then this larger stream will make another large stream. So this is a very general characteristics of the stream forming a river, and it is seen in most of the rivers. Then we have parallel pattern. Here the tributaries, they run parallel to each other before meeting the master branch or the main branch, generally formed on regions having uniform slope. So when the slope is very uniform, very consistent slope is there, then you will see that there will be parallel streams will be there. They will be flowing along the slope in a parallel direction. So here is an example of dendritic drainage pattern where we can see that they are more or less not very uniform. The direction is not very uniform. However, here we see that these are parallel drainage system, and here you can see that the direction of these streams is almost very consistent. Now there is not much difference between both of these, but here you will see that the sub branch can come from various directions. However, here they are more or less, they originate and they flow a consistent direction and then meet the main branch. Even here we can see that for this topography, earlier we saw for dendritic pattern, but here we can see that they will flow in a parallel direction from the slope and then they will meet downstream somewhere. So we have seen generally formed on regions having uniform slope. These the rivers of Himalayas and Western Ghats form this kind of pattern. So here is an example. Here we can clearly see that this is our Sivaliks. And in this Sivaliks you can see these river branches. These are all rivers, and this kind of pattern is basically a parallel river pattern. We can see that most of the rivers here are flowing parallel to each other for very significant distance on both sides of Sivalik. So this is a very good example of parallel drainage pattern in India. Next is Trellis pattern. Now this is a little different. It is formed by consequent river. The meaning of consequent river we will see in the next video, where it basically means that rivers which follow the general slope of the landform. So here they are formed by the rivers which follow the slope of the region and its tributaries. They follow regional slope. Develops in areas of simple folds characterized by alternate anticlines and synclines. So this is basically an example of trellis drainage pattern. Now how they are formed we can see over here. So consider this as a landform where we have synclines. This is the syncline, this region. This is also a syncline. So basically it is a downward fold of the landform, and here we have the anticlines. These are the upward folds. So these are all the upward folds. Now naturally a river will flow in these parts because it is the lowest point. So most of the rivers will follow this slope in the syncline, but there will be some streams which will originate over here. Now they will not flow along the anticline, but they will directly follow the slope and meet this river. It would be something like this. So it would be something like we just saw that the rivers which will originate from here, they will meet the main stream. Now these tributaries of the main branch, they are very parallel to each other. So earlier we saw it was parallel stream. Later we will saw a rectangular pattern, but this is trellis pattern, and here we can see that these streams, they meet the main river at the 90 degree, and they are generally formed in the regions which have such kind of landform where there is the syncline and anticline. So it develops in areas of simple folds. These are the simple folds characterized by alternate anticline and syncline. So this is anticline, this is syncline, forming parallel syncline valleys. So these are the valleys. These are syncline valleys. Several longitudinal streams develop in the elongated longitudinal valley. So there will be several streams. Even here also there would be a stream. Even here there would be a stream. Several streams develop on the flanks of the ridges. So these are the ridges. The anticlines, they form the ridges and join the longitudinal stream at right angle. So remember, they will join them at almost right angle, as you can see over here. So they are developing over this ridge, then flowing down the slope and then meeting the main stream. Now the example is Appalachian Mountains or even our Dune Valley. So here in this image we can see the example of Appalachian Mountains of US. So we can see that these are the ridges and here are the synclines or the valleys. So here we cannot see because it is a zoomed out view of the landscape, but there are rivers which will originate from this ridge and they will flow and meet the main stream which is flowing in these valleys. If you zoom in this region in your Google Earth, then you will find rivers over here and then rivers, streams originating and meeting the main river in these valleys. So this kind of area where there are where this kind of landform where there are ridges and then valleys, there you will see the trellis pattern. Now let's see the rectangular pattern. Now even in rectangular pattern, the tributaries do meet at nearly 90 degree, but it is different from the trellis pattern which we saw in the previous slide. So tributaries join master stream at right angles. It develops in region with rock joints having rectangular joints and fractures. So earlier it was because of anticline and syncline. Here it is because the underlying rock structure is having fractures which is at 90 degree. Like here you can see that this is the underlying rock and there are this kind of fractures which are 90 degree. Now these kind of fractures do occur in the nature, and therefore you will see that the streams in this region, they will follow this kind of fractures and they will merge to form a river. So this kind of stream or this kind of region, it develops into a rectangular pattern. So here we can see the difference. Trellis, confluence angle guided by strikes and dip angle of rock beds. So here we are seeing the difference between trellis and rectangular pattern, and it says that the angle is guided by strikes and dip angle of the rock beds. So basically, if there is these two rock beds, or if there is one rock bed and it is tilting, the tilt of that rock bed, it will decide the flow, and it is closely spaced tributaries. So there will be a lot of tributaries which are flowing from the ridge in the valley, and they will be closely spaced as we saw in the previous slides. But in rectangular pattern, confluence angle determined by faults and fracture. So remember, here it was by the strikes and dip angle of the rock beds. Here it is by the angle of the fractures. And generally the tributaries here are widely spaced tributaries. Now rectangular pattern is not very common, but it is still seen in a lot of places. And remember, it is not perfectly 90 degree, but it is close to 90 degrees. So here we can see that there is a landform which is undergoing a folding, and during this folding it can have these kind of fractures. So this kind of region eventually forms a rectangular pattern. Here is another example where we can see there are fractures, and these fractures are 90 degree with respect to each other. So if a river or a stream is formed in this region and this region, so they will merge at 90 degree, and they will flow here, they will merge another stream over here. So this will also lead to a 90 degree meeting of the substreams, thus creating a rectangular pattern. Here is a region, a landscape, where we can see a river. This is the main river flowing over here. So this is a region in central USA, and this is a very zoomed out view. So this is actually covering a large area, and you can see that there are rocks which are having the faults at 90 degree. Here you can see this is also having faults. Here we can clearly see that these are the areas where the faults are at 90 degree with each other, and that is why the river which is flowing over here, it is also having almost right angle turns, and there are tributaries which we cannot see because we are zoomed out, but here there is a tributary which will join it like this. There will also be a tributary which will be coming from here and join it like from here. So this kind of pattern which is developed because of faults in the rock is called rectangular pattern, and I hope you understand how it is different from trellis pattern. Here is another example of Colorado River, and even the Colorado River, you can see that this is the main Colorado River, and here at a specific location you can see that these are the tributaries which are joining the main river at 90 degree. Now radial or centrifugal pattern. Now here streams diverge from the central high point in all directions. So what happens in this kind of pattern, that there is a central highland, it could be a hill, it could be a plateau. So rivers originate from there and they flow in all the directions, as you can see over here. So this is a central region. One river stream starts like this, another stream starts like this, then there is this others. So these are the streams which start from a very close by place and then flow in different directions following the slope of that region. So central highland can be dome structure, volcanic cone. A volcanic cone, if it is very big, then several streams can develop. It is not required that all of them develop on the peak of the mountain. They can also develop midway in the mid height. It can develop from here, and still it will be called as radial or centrifugal pattern. Rivers are consequent streams. Consequent means the rivers or the streams which follow the local slope of the rock. Entire examples are entire pattern of Sri Lanka. So if you see the Sri Lankan island, which you will see in the next slide, so it is having, most of the rivers here are having radial pattern because there are central highlands which descend in altitude on all directions. Then we have South Koel River, Subarnekha, Kanchi and Karo rivers southwest of Ranchi city. So even in the Chota Nagpur plateau, you will see that there are regions which have this centrifugal pattern. Now here is a 3D view of our Sri Lanka, and we can see that in Sri Lanka, in the central part of the Sri Lanka, we have this kind of mountains, while on all these sides you will see that there are plain regions. So height is very high in the center, and then on the coastal regions the height decreases. So there is this decrease in height from the center towards the coast in all directions. Even here you can see that these are the mountains, and as we descend towards the coast, the height decreases. So the river pattern over here is basically the radial pattern. We can see the rivers now here. So these are the rivers. Sorry, this is an example of a hill in US. So here you will have, if you see the map and the rivers, they will be flowing from the hill towards the coast. This is another example from central US, where we can see that here is this mountain, Black Hill Mountain, and there are these rivers which are flowing away from the central highland in all directions. So this is another example of our radial flow. Then there is centripetal or inland pattern. Now here what happens is streams converge. In the last, the streams diverged. Here the streams converge in a depression. So in the central region there is this depression. Now water from the surrounding region, it will make a stream and then flow into this depression. So water will collect over here. So here is a figure. You can see that there is this central lowland, and streams from all sides, they will flow and meet within this lowland. So this is basically a converging example, and Kathmandu Valley is an example of this. We will see the map. This is the map of Kathmandu Valley, where we can see this is the Kathmandu Valley, and there are mountains on all the sides. Basically what happens that because of this mountains on all the sides, the streams, they develop on all the sides, and then they descend in the Kathmandu Valley. There are other examples of this. Basically the basin region of USA is also an example of centripetal river pattern. Now annular or circular pattern. Now this is formed on hills, but here what happens that there is a central stream which flows down the slope. It is formed when tributaries of master consequent stream develop in form of circles. The pattern is developed over mature and dissected dome mountain having alternate bands of hard and soft rock bed. So let's understand, we have seen the radial pattern. So in radial pattern there were the river streams which originated from the central highland and they flowed in the all directions, they diverged. But here in this mountain we can see this is our one stream. There will be similar streams on all directions, but here you can see that there are two types of rock. This is one type of rock, this is another type of rock. Now let's consider that this type of rock is soft rock, and these are hard rocks. There will be bands of this type of rock. There will be several layers of these rocks. So there could be another band over here, there could be a third band over here. So over the time what happens that these softer rocks, they will be eroded by the stream, and we will see a new tributary is created, and it will have a circular shape. So here we can see that this there was this erosion by this main river, and then these tributaries were created. So so there will be other branches, and they will also create this same type of tributaries. So this kind of pattern is called annular or circular pattern, and here we can see a top diagram where we have these kind of independent streams. These are the main streams. Here also there is second stream, third stream, fourth stream, and then there are these tributaries of this river which are eroding the softer rocks or softer bands, which are circular bands, and thus they are creating this circular pattern. So this kind of river drainage pattern is called annular or circular pattern. This pattern develops over mature and dissected dome mountain having alternate bands of hard and soft rock. So basically, generally there is a requirement that there should be a harder rock and a softer rock layer, so the river can erode those softer rocks. Differential erosion of hard and soft rock bed results in truncation of the beds, which produces ringed belted structure. So ring-like structure is created, you can see, because the softer rocks will be eroded more with a higher rate compared to the harder rocks. If there were only harder rocks, then generally all the rocks will be eroded at similar pace. So this kind of pattern might not develop in those rocks if there is symmetry of rock. But when there is hard and soft rock, then the soft rock will be eroded at a higher rate, and therefore we can see formation of this kind of patterns on this. When we are seeing from the top, this is the side view, so there will be similar streams from all other directions creating this kind of branches. I hope you understand the annular or circular pattern. This is a region where we can see that the river streams are not visible, but here again this is the region, and there are certain rivers which create the annular pattern over here, but it is not visible in this screenshot. Next is barbed pattern. Tributaries flow in opposite direction to their master stream. Now this is a very different kind of flow, where we see that the flow direction of the tributary is opposite to the main branch, and it is formed by river capture. Mainly it is formed by river capture or even tectonic activity or glacier activity. Arun River of Kosi is an example of barbed pattern. Now let's try to understand from these diagrams how it is created. So here is example of river capture. So here we can see that there are two rivers. This river is flowing in this direction, this river is flowing in this direction, and this blue line, it indicates the divide. There is a mountain over here which is dividing these two rivers. On one side water is flowing down the slope, on the other side the water is also flowing in another direction. Over the time, this region, it may be eroded by this river. There it could happen that this side could have higher slope, and if there is higher slope, the erosion will be higher. So let's consider that there is higher slope, the erosion is higher, so this river will expand. Here we can see, and now it has captured a lot of tributaries of this river because of erosion. Now we can see that this tributary, which was originally flowing in a downward direction, now it has joined this barbed river, but the flow, the initial flow of this stream is in its original direction, but later it changes its direction to meet the main river. So this tributary or this kind of flow is called barbed pattern because it is moving in the opposite direction. The main river branch is moving in this direction, while here we can see that the river water is flowing in this direction. So they are in the opposite sides. This is also an example of river capture, where we can see that there are streams which have changed their direction. So here we can see that the water is flowing in this direction. Before river capture, there is this divide, and now this divide has been eroded. You can see that the direction was in the downward side, but now the flow has changed. But here you can see that they are flowing in opposite direction. The main river is flowing in this direction, but because of river capture, the direction has changed of this flow. But even because of change in direction, the direction flow of this pattern is opposite to that of the main river. So because of this and this particular branches, their flow is opposite, and that is why it is called barbed pattern. We can see here, this is one river, and these arrows indicate the direction of water flow in this river. Now suppose over the time, what happens, there is another river which captures it. Now we can see that there was change in direction of water flow over here as well as over here, but this stream continues to flow in its original direction. Now water will be flowing in this direction in this, but here it is flowing in this direction. So this has become opposite to this. Therefore this is an example of barbed pattern. There is another video over here where we will try to understand how tectonic activity can lead to barbed pattern. So here there are three rivers which are flowing in. They are not connected as such, but consider that there is some tectonic activity over millions of years and a mountain is created in this region. Now because the mountain is created, the flow of these two is obstructed because they were not able to cause erosion. So the water from which is coming down slope, it has to form a new stream. It has to change its direction to meet this stream, and in this particular case it reverses the direction because to adjust the new mountain over here. So here also we can see that it is actually for a very short distance but flowing in direction opposite to this main branch. So this is also a barbed pattern example. Now let's see the deranged pattern. The deranged pattern is basically a river which does not have any pattern, no coherent pattern of stream flow. It is generally develops in region with multiple geological disturbance. So if there is certain region or area where there are a lot of tectonic activity, glaciation, erosion, all these have been repeated in a very short span of time. Short span means like millions of years. So because of this, what happens that there are multiple slopes and rivers could be superimposed or rivers could have be antecedent to the slopes. So because of that, there is no general pattern of flow of streams in that region. Canadian Shield is a very good example of this. There were tectonic activities, there were glacial erosion which has carved the area during ice age. Melting of ice has left a terrain with uneven pattern. And here you can see these are the rivers, and if you see the direction is actually very complicated. It is very difficult to see that there is any general direction. Some rivers will flow in this direction, some parts river will flow in this, and then they will turn, others will go in this direction. So because of the glacial erosion, the direction of river flow changes in very short distances. So this whole region, if we take into account, it does not have a fixed pattern, and this kind of pattern is called deranged pattern. So with this, we have covered all the important river patterns in this classification system. On the internet, you could find certain other classifications, but it was not important, so we did not cover it. But the basic understanding would remain the same. In the next video, we will see the consequent, insequent, the superimposed antecedent river classification. So do watch those videos. Thanks for watching this video. If you like the video, then do subscribe to the channel and share it with your friends. Thank you.